Hey guys, this video is on Pure 2 Chapter 9, which is differentiation, and in this video I cover exercise 9a questions 9 and 10. I've already done two videos which I covered questions 1 to 8 of exercise 9a. So if you are interested in watching those questions first, feel free to watch those videos first and then come back to this one. Right, let's get started. Okay, question 9. A curve has the equation y equals 2x squared minus sine x. Show that the equation of the normal to the curve at the point with x coordinate pi is this equation. Right. So there are two things that we need to be aware of. The first thing is that whenever we want to find an equation of a line, we need a set of coordinates and the gradient. So in this question, our first goal is finding these two. So the question has given us the x coordinate of the point, but we need to find the y coordinate by ourselves, which is so simple. So we have the equation which is y equals 2x squared minus sine x, and we need to know the y coordinate at x equals pi. So it's going to be 2 pi squared minus sine pi, and sine of pi is 0. So it's just going to be y equals 2 pi squared. So now we have the coordinates of the point, which is pi and 2 pi squared. Now we need to find the gradient of this equation at this point. So let's find the gradient of the equation at this point. So we'll start by differentiating the equation. So we write dy by dx, which is going to be 4x minus cos x, because minus sine x differentiates to minus cos x. And the next step, because since we are looking for the gradient or gradient at pi, so we sub pi into our tangent equation, which is going to be 4 pi minus cos pi. And 4 pi, we just write that. And cos pi, it's going to be minus 1. Since it's minus cos pi, it's going to be minus minus 1, which is plus 1. So minus minus 1, which is plus 1. But now the thing that we need to pay attention is that we are looking for the equation of the normal. And now we've found the gradient of the tangent to the curve at that point. So whenever we want to find the gradient of the normal, we just do minus reciprocal of the gradient of the tangent. So if we do so, it's going to be minus 1 over 4 pi plus 1. So this is the equation of okay, now we found the gradient of the normal, and now our job is to find the equation of the normal and then rearrange that to get in this form. Right. So the equation of a line is y minus y1 equals the gradient times x minus x1. And now we are going to use the gradient that we found and also the set of coordinates that we now have in order to find the equation. So it's going to be y minus y1, which is 2 pi squared, equals gradient, which is 1 minus 4 pi plus 1. Then it's going to be x minus our x, which is pi. Okay. Since we want our equation in this form, we need to get rid of this 4 pi plus 1 in our denominator. So we multiply both sides by 4 pi plus 1, which is going to be 4 pi plus 1 um, times y minus 2 pi squared. Then it's going to be minus x minus pi. And now we expand this, it's going to be 4 pi by minus 8 pi cube plus y minus 2 pi squared minus x plus pi. Right. Now we need to move everything to left because here if you see in right we don't have anything. So now it's going to be 4xy minus 8 x cubed plus y minus 2 pi squared plus x minus pi equals 0. And now we need to do factorizing, and we can use the final answer to use in our factorization. So we just write x, and also by using this we can now factorize y. So it's going to be 4x because this is 4xy, and also we have a y here, so it's going to be plus 1. And the second step is factorizing minus pi. So we do minus pi, and here it's going to be minus 8 pi squared. Now it's going to be plus pi plus 2 pi, and also here it's going to be plus 1. Okay, that's it. And we now have the equation in the form the question has asked us. That's it. Okay, now is question 10. Prove from first principles that the derivative of sine x is cos x. You may assume the formula for sine a plus b and that these two. Okay. The very first thing that we need to do is remembering and writing down the addition formula for sine x. So it's sine a plus b, which is going to be sine a times cos b plus cos a times sine b, because in this question we are going to use this. Right, and now we need to prove this by first principle. So as usual, we do let f of x equals sine x, and then we write f dash x equals limit of as h tends 0, and here is always h and f of x plus h minus f of x. So that's the very first step that we do whenever we are using and proving from first principle. Now the next step is going to be using our function, which is sine x in this question. So it's going to be sine of x plus h minus sine x over h. And now we can now expand this by using the addition formula. So it's going to be sine x times cos h, and it's going to be plus sine h times cos x and minus sine x. Right. Now the next step is factorizing. So in our next step, we write limit of a as h approaches 0, and then it's going to be, we can do factorizing. So the first thing that we can do now is, if you see we have sine x here and also sine x, so we can factorize sine x. So we let's do it now. Okay, sine x, and it's going to be cos h minus 1. So that's the very first thing that we did. And also, so we use this and also this. So now we write sine h times cos x. And now the next thing that we can do is basically rewriting that in this format. So it's going to be a limit of as h tends 0. Then we can separate the two fractions, basically separate it into two fractions. So it's going to be um, cos h minus 1 times sine x over um, over h, and is and the second one can be written in sine h over h times cos x. Okay. Let me just change that a bit. So it's exactly the same thing. I'm just going to change this slightly. Okay, that's it. Because we want to, change it to a format that we can also use this to hints as well. Right. Now the next step that we are going to do is basically considering these two hints, which says that sine h over h tends to 0 as h approaches to 0. Sine h over h also tends 0. So if you see, here should now be 1 according to this, because it's now 1 and 1 times cos x. And also about this one, it's as h tends 0, cos h over 1 over h tends 0. So this one is going to be now 0, and 0 times sine x is just going to be 0. So the only thing that now we are going to have is going to be basically 1 times cos x, which is cos x. So now we've proved that sine x equals cos the derivative of sine x is cos x. So let's just write that in a better and more mathematical way. So now it's going to be so limit of h tends 0 of sine x plus h minus sine x over h is going to be cos x. That's it for this question. Okay, thanks for watching, and please subscribe for more videos.